everybody, let's learn another thing about circles. There's a type of line called a tangent line. That's this one right here that goes through point I. And it's a line that touches a circle in just exactly one spot. So there's plenty of lines that might intersect with a circle more than once, but a tangent line intersects with a circle at just one point, which is called the point of tangency. In today's lesson, we're going to learn how to write equations for tangent lines. So first thing that I thought we could practice, though, is just for review, let's practice writing an equation for this circle. So we need to know two things. We need to know the center and we need to know the radius. So I just counted the boxes to find the center and I saw that it was at 12, 11. For the radius, I realized that I didn't really want to find the length of the diagonal line, GI. So I drew in a different radius that was horizontal because I thought that that would be easier to count, and it's 10 boxes long. So let's use that information to write the equation of the circle. So x minus 12 squared plus y minus 11 squared. I plugged the center of the circle into my equation. Equals radius squared, and the radius is 10, so radius squared is 100. All right, let's see what we're asked to find next. It says find the slope of GI. So GI is the radius in this picture. If my highlighter will work, I'm trying to highlight it. There we go. For some reason, it wasn't working there for a second. In order to calculate that slope, let's find the rise and the run. So I'm going to count to find the rise. Oh, I went up too far. Let me try that one more time. Let's count to find the rise, and let's count to find the run of how to get from G to I. And it looks like the rise is 8 boxes and the run is 6 boxes. And that makes sense because that would make a 6, 8, 10 triangle, which is a Pythagorean triple. And we know that the radius is 10. So the slope of the radius is 8 over 6. Let's do a quick calculation to find the slope of the tangent line and see if they're related at all. I'm going to switch colors again. How about purple? So let's find this rise and run here. Let's find the slope of the tangent line. It's going down for the rise, so it's going to have a negative slope. And when I count the boxes, I see that it's down 6 over 8. How is that related to the slope of the radius that was up 8 over 6? I just realized that's something that we learned earlier this year. Those are opposite reciprocal slopes, which means that they're perpendicular to each other. If you look at my yellow tangent line and my blue radius, do you see that they make a perfect T? They make a right angle. They are perpendicular to each other, and that will actually always happen every time that you draw a tangent line and you draw a radius to that tangent line. They're always going to be perpendicular to each other. So if I know the slope of the radius, I know the slope of the tangent line. So the tangent line has a slope negative 6 over 8. In order to write an equation for a line, I need a slope and I also need a point. So let's go back to the picture. I see that point I is on the tangent line, and if I find its coordinates and count, it is at 18, 19. So that's what I'm going to use for my point. Now we are going to flash way back to something that we used to do at the beginning of the year all the time, which is to write an equation for the line in point slope form. We have a slope and we have a point, so all we have to do is plug in those numbers. So the y coordinate is 19, the slope is negative 6 over 8, and the x coordinate is 18. And if I clean it up a little bit, I have a perfect equation for my line. All right, let's try to do a couple more examples when there's not a picture. So let's flip to the back. And it says to write an equation for the line tangent to this circle at the point 8, negative 6. So I know that I need to find the slope of my radius. And to do that, I need to know the center and the point of tangency. So I know the point of tangency already is 8, negative 6. The center of my circle, if I use what I've learned in this unit, if it's x minus 4 squared, that's positive 4. And y plus 9 squared, that's negative 9. So that is the point for my center. The point of tangency is at 8, negative 6. And I need to take those 2 points and find the slope. So it's been a little while since we have found slopes on a regular basis. But what we used to do was we used to highlight the y is in yellow and the x is in blue, and we would just do the change in y, yellow minus yellow, over the change in x, blue minus blue. And I can use my calculator to do the subtraction. I get 3/4. Well, what did we learn on the front? We don't actually want the slope of the radius. We want the slope of the tangent line, which is perpendicular to the radius. So instead of positive 3/4, I need to do the opposite reciprocal, negative 4/3. All right, I have my slope now. Do I have my point? Well, make sure you don't use the center because the tangent line doesn't actually go through the center. It goes through the point of tangency. So I have my point and I have my slope. So I am ready to write the equation in point slope form. The y coordinate's -6, the slope is -4/3, and the x coordinate is 8. So I'm going to clean it up a little bit. Instead of y minus -6, I'm going to write y plus 6 equals -4/3 x minus 8. And there is the equation for my tangent line. Let's try one more, basically the same thing, but we're going to take it up a little notch because I cannot just find the center by looking at this equation. I have to complete the square. So we're going to use what we learned earlier in the unit and add some blanks to complete the square so that we can find what the center of the circle is. So we need to take the 2, split it into 2 parts, 1 and 1. 1 times 1 is 1. So that's what I'm going to put in this first blank. And then I need to split the 12 into 2 parts, 6 and 6. So 36 goes in that blank. The right-hand side to me is the easiest part. It doesn't actually really matter in this problem, but I can add up 132 and 1 and 36 to get 169. But we're not even going to use that number. What I'm concerned with is the left-hand side of the equation so I can figure out the center. So x plus, and then what did I square to get 1? 1. Y minus, I'm using the sign in front of the 12y. What did I square to get 36? 6. So now that I have my equation, now I can pick out my center is -1, 6. I must have been given another point also, so I need to go back to the original problem, and the point that I was given was 418, and I need to find the slope. So I'm going to highlight the x's and y's again. And let's find the slope where we subtract the y's on top and we subtract the x's on the bottom, and we get a slope of 12/5. But we don't actually want that slope. We want the opposite reciprocal slope because the tangent line is perpendicular to the radius. So I don't want positive 12/5. I want -5/12. And now I have my slope and I have my point. So I am ready to write my equation. All right, y minus 18 is the y coordinate, -5/12 is the slope, and x minus 4 for the x coordinate. And I will clean it up, and that is the equation for the tangent line. Let me know if you have any questions. Bye.